Hello everyone, this is Mrs. Braband and I am going to be showing you a video that will match the target sheet that we've just started on Unit 3. We're actually calling this Unit 3A. We'll get another target sheet when it splits up to more information about polynomials. So I'm going to try to do a video per target. So the first video I'm going to do might be a little short. It's just going to be on target 1. Again, our focus is on polynomials, which means expressions that have more than one term, like number 1. And then all those rules that we handle with the exponents that we see in each one. So there's some operation rules with exponents. There's definite discussions with what do the exponents all do, what do they mean, and we'll get into those per different target. So let's start with target 1. This is classifying, rewriting in a certain order, and then talking about its degree. Now sometimes like in number 1, the degree is important because it'll tell us a graph. But when you get to number 2, the degree is just kind of a counting classifier because we're not going to be graphing 3 different letters at a time in a 3D format. So it's just telling us what the degree is so that if something like this monomial shows up in the middle of a polynomial, we know how to handle it. So again, first one, number 1, 1, 2, 3, 4, 5 terms. This is a polynomial with 5 terms. Standard forms means write it in very specific order with the highest power first. So as I look at all 5 of these, the highest power is the 4th one. So whatever coefficient is attached to it goes with it. The next highest power would be this one with the 3rd, because you always want to go 1 down in descending order. Again, you're going to take the coefficient. Keep going in order, downward, descending. Keep taking the coefficient with it and the sign. Second power. So now we're down to the first power. It looks like we're here. The only thing that's going to go wrong on these, you guys, is just to go too fast and make a silly mistake because you're out of order. So I would say you got to practice patience here and organization. The last one does not have a letter, which means it's really a power of 0 on that letter. And that means it's a constant. So there's your standard form. Once you've got it in the right order, and even before, to be honest with you, as long as you understand the highest power, which again was this one, that's the degree. So this is a 4th degree polynomial. Okay. The lead coefficient is the number that sits in front of that high power. So in this case, the lead coefficient is -8. Since this polynomial, let me give you this original back, is single variables, it's possible we could probably graph this in a graphing calculator like Desmos or something. And what would happen would be we'd have the 4th power would tell us we'd have possibly 4 x-intercepts or less, and the -8 would tell us that our graph would be stretching and then open and downward. We're not going to get into graphing right now, so I just pointing that out. The second one is not a polynomial. This is actually a monomial. That means a single term, no plus and minuses surrounding it. So when we do that, we find the degree differently. It's not the highest power, believe it or not. We have to count all of our possible exponents and add them together to get the degree. So again, you're going to add all exponents together to get that degree. So we've got, and we don't need to worry about a standard form too much as far as the first one is concerned because there's only one term, but we do need to write it in alphabetical order. So x goes first with its power, y goes second with its power, and z goes third with its power. That's standard form. And then let's count for this degree now. We have 1, 2, 3, 3, and 5 is 8. 8th degree monomial. The lead coefficient is the number that sits in front. The third one is a combo of the first 2 problems, because if you can see it, we've got little monomials with extra letters separated by plus and minus signs, and that's what makes this a polynomial, but each piece has its own degree, own degree, own degree, own degree. So we're going to find each degree. 1 and 1 is 2, looking at only the powers. 2 and 3 is 5. That's a single 2, and that's a single 1. And then the highest power is going to be the degree. So this is a 5th degree polynomial with 4 terms. Standard form is writing it in order, which gets a little crazy when you have more than one letter. So what you tend to focus on is one letter at a time. I'm going to choose to do y's and go from there. So the biggest y value is the 10 one. So 10x squared y to the third. Then grab the one with the next highest y, that's here, minus 2xy. Then you look for the other y's, which there's not. So some rules are if you're in a different letter, you want to go in a different order, meaning low to high. This one is not as concrete of a rule because you have so many different powers and letters, it's just too random. So as long as you pick one variable and follow it, you're good. The lead coefficient is the first one, a meaning first. This is your highest power, your lead is 10. So that is a variety of finding out how do you put things in the right order for organization. Once you have it in order, what's the degree on each one? The lead coefficient goes with what the degrees power is. And then the trickiest one, I think, to be honest with you, is because people just forget it. How do you find degrees if there's more than one letter? And that's really just adding all your powers together as a count. So that is target 1. We're going to end this, and then I'll start a new video for the next lesson. Thank you.